Hello students, in this video we will be seeing about thin film interference and a special experiment to prove the thin film interference that is called as the Newton's ring experiment. This is one of the most important deleted topic that is found in all the entrance examinations like Amrita, VAT, SRM, etc. Watch this video till the end. I have solved some previous year questions from all these entrance examinations. Let's get started. What is a thin film? A thin film can be anything like a soap bubble or an oil drop. If you see an oil filled in water, you can see some rainbow colors that is popping up. This is due to the thin film interference that is happening in the oil water surface. Basically, a thin film is a transparent layer of material with the thickness which is comparable to the wavelength of the light. So the wavelength of the visible light ranges from 4000 angstroms to the 7000 angstroms. So when a light is reflecting from a thin film interference, some part of it is transmitted and some part of it is reflected. So because of the thickness of the film, we have some part of it which is reflected after hitting the inner surface, and they both interfere to form an interference like pattern which will be producing bright and dark fringes. So basically, if we use monochromatic light, we are going to get bright and dark fringes. If we use white light, we will be able to get a colored pattern. So when an oil is spilled in water, we are able to see the colored rainbow-like effect because of the rays that are interfered is white light. In this slide, we can see what is a thin film. So there is an incident ray. Part of the incident ray is getting refracted and part of the incident ray is getting reflected. And this is the film. This thickness of the film is comparable to the wavelength of the light, that is in the Armstrong range. The refracted ray that is passed through the film is again getting reflected back and it comes out of the first surface like this. This first ray and the second ray will interfere because the path difference produced is very, very less comparable to the wavelength of the light. So this path difference is introduced by the film. So this interference pattern between 1 and 2 will be causing our bright and dark fringes. So when we are having constructive interference, will be able to get bright fringes. When we are having destructive interference, we will be getting dark fringes. The path difference formula that we need to remember, which is introduced because of the ray, is 2 into mu into T, where T is called the thickness of the film and mu is the refractive index of the film. And bright fringe occurs at the path difference delta x is equal to m plus 1 by 2 into lambda. And dark fringe occurs at path difference 2 mu t is equal to m into lambda. This formula you need to remember. Now, Newton's ring. So Newton's ring is a concept which was observed by Newton. It is a thin film experiment which is observed when a plano-convex lens is kept above a glass slab. Because of the air gap between the surfaces, we will be able to observe constructive and destructive interference, which will produce bright and dark ring-like structures. So the radius of the nth ring is given by the formula Rn is equal to square root of n into lambda into r. This formula you need to remember. So here in this diagram you can see the Newton's ring experiment. It consists of a microscope and a glass plate which is tilted at 45 degrees centigrade and a light source which is made parallel by using a convex lens. As you can see here, the thickness, the air gap that is lying between the plano-concave lens and the glass slab is varying, right? So this air gap is given by the formula T is equal to R square upon 2 into R. This is a formula that we need to remember, where the air gap varies. R is the distance from the center to the left side or right side, and capital R is the radius of curvature of the plano-convex lens. The derivation of this Newton's ring is not as important for your examination point of view. You just need to remember the formula and the questions will be direct applications of the formula. You can see, unlike the interference in soap film, etc., you can see here the thickness of the air gap is varying. That means the thickness is varying. So when a ray is entering here and partly it is getting reflected and refracted, and the refracted ray again gets reflected, and they both interfere to produce bright and dark fringes. This bright and dark fringes will be of varying intensity and with varying distance of separation because the thickness of the air gap is varying. That means the thickness of the path difference, which is equal to 2 into mu into t, is varying. In the original thin film interference, the path difference is constant because the membrane is like this. But now here you can see the air gap is something like this. So the thickness is varying, but here the thickness is constant. In both cases, we have the path difference is given by 2 into mu into t. So here the thickness is constant, here the thickness is variable, given by this relation r square upon 2 into r. So because of the varying thickness, we will be observing a concentric rings like this. The ring spacing will get closer and closer as we move far away from the r. So this pattern, wherein the center is dark and other are bright, dark, bright, is observed when we are observing the interference of the reflected ray here. Similarly, if we look from the bottom, from the below, if we see that, we will be observing the interference pattern of the refracted ray. I mean the transmitted ray through the glass slab. This transmitted ray will introduce only 0 or 2 pi phase difference. That means in the center, we will be having bright and then dark and bright and dark. Same ulta of this we will be getting if we observe it from the below. So when we observe the pattern from the below, we will be calling it as Newton's ring from the transmission. When we observe it from the above, we call it as Newton's ring due to reflection. These 2 points you need to keep in mind, the reflected pattern or in the transmitted pattern. So this Newton's ring and thin film interference, there are so many interesting real life applications like soap bubbles. The colors that you see in the soap bubbles is because of this thin film interference. And as I told earlier, the oil films, when petrol is spilled on water, will have a rainbowing effect. And some butterflies in nature have this kind of iridescent effect. This iridescence is also another name given to the thin film interference concept. So these are some of the previous year questions that I have taken. So the thin film is given, mu is given as 1.33, thickness is given as, so the condition for the constructive interference is delta x is equal to m plus 1 by 2 into lambda. For destructive interference, it is m into lambda, where delta x is given by 2 into mu into t. Next, another question, find the diameter of the fifth ring. So in the Newton's ring experiment, there is a formula where the radius of the nth ring Rn is equal to square root of n into lambda into r. So directly you substitute the value, n is equal to 5 here. So r5 is equal to square root of 5 into lambda into r, where r is given as 1 meter, and you will be able to get the answer. Next, why is Newton's ring center dark? When we are observing the reflected rays, the center fringe is dark because of the destructive interference. Then another question, if the radius of curvature of the lens double, that means the capital R doubles, what happens to the ring radius? So we know the ring radius Rn formula is square root of n into lambda into r, so which is directly proportional to r. When the radius doubles, that means the Rn will also be equal to square root of the original value. So it is directly proportional to square root of r. So in Newton's rings, we need to remember these formulas and apply according to the question. If you understood the concept, like this video and subscribe to our Easy Exam Academy channel and share it to your friends. Bye.